Welcome back. In this video, we will be talking about data and how you handle different types of data. Let's get started. The book we are referring to is Introduction to Data Mining, second edition, and all the slides in this video have been sourced from the website of the book. So you can refer to the website of this book, Introduction to Data Mining, second edition, for the original slides. If we talk about data, generally data is organized as a collection of records or objects. So if you see here, this particular row and the entire thing is known as a record, then the columns are known as attributes. So the rows are records and the columns are attributes. Records are also known as objects or data points or cases or samples. For attributes, you can call them variables. You can also call them field or a characteristic, a property or a feature or a dimension. So these are data dimensions and these are data points. Mostly, if you will be given some data to mine, it will be organized in this form, having records in the rows and the project property of each and every record in the columns. The attributes values are basically numbers or values assigned to a property or an attribute of a record. Some attributes can be mapped to different attribute values, like height can be measured in feet or meters, or temperature can be measured on a Kelvin scale or as Fahrenheit or degree centigrade. Different attributes can be mapped to the same set of values. For example, ID is an integer and age is an integer, but their properties can be different. The way you measure may not preserve attribute properties, and sometimes it may preserve the properties. For example, if I map A, B, C to 1, 2, 3, it is basically preserving the ordering property as well as the additive property of this particular these particular attributes. But if I map them to this particular scale, from A is mapped to 2, B is mapped to 3 and C is mapped to 5, I'm only preserving the order. So it depends on your application how you are transforming the data and what is your requirement. Do you need only ordering is important or additive property is also important? Then only you will be able to choose the correct transformation function. Then there are various kinds of attribute types. You have nominal attributes. Sometimes it is also known as categorical attribute. This is known as categorical attribute. And then you have ordinal attributes. See, so the categorical or attribute could have, values or classes as A, B and C. Or it could have, for example, you have a very popular data set which is known as iris data set for iris flower. So there are category called setosa. So this is a category for a for iris dataset. So the flower is defined into various categories. Or if we talk about different kind of viral infections that we have, pandemics and epidemics that we have had. So MERS was a virus. So that is one category or one nominal attribute. Then you had a coronavirus. So coronavirus. Then you had SARS virus. So these are all known as categories, and the attribute that will hold these values will be known as a categorical or a nominal attribute. Then we talk about ordinal attributes. So they also have categories, but there the order is also important. So for example, bad, fair, good, excellent, grade A, grade B, grade C, grade E. tall, medium, short. Or what about the reviews? For example, if you give a review as very bad to great, excellent service, so all these things are ordinal. Or probably ranking of employees in an organization, assistant, and then senior assistant, then probably professor, and so a lot of things like that where order is important. Then interval is like calendar dates or temperature in Celsius or Fahrenheit. So where you can measure from and to, these are interval attributes. Ratio is temperature in Kelvin scale. As you know that Kelvin scale is calculated as in the terms of ratio. Or you can, for length and time also, you can take ratios. For various counts you can take ratios. So some attributes are in the form of ratio attributes. So all these things are important because when you will be processing this data and then analyzing this data, so different techniques will work for nominal, some will work for ordinal, some will work for interval, some will work for ratio. Not all techniques will be applicable to other attributes. So generally in nominal, because you can either identify if a category is distinct by equal to or not equal to. Ordinal, where distinctness is important, and you are going to check the order, and you can compare with them with greater than, less than, or greater than equal to, less than equal to. In interval, distinctness is important, order is important, and meaningful difference of the interval is also important. You should be able to take the difference. So plus and minus operations also come in ratio. As the name of the attribute suggests, you can perform multiplication and division operations also. Moving ahead, so this is a screenshot, the snapshot that we have taken from the book by introduction to, from introduction to the data mining. So nominal and ordinal attributes are categorical attributes, and they are qualitative in nature. And interval and ratio are numeric and quantitative in nature. So these are the operations that we have already discussed, the examples that we have already discussed. And in nominal attributes, you can compute the mode, the maximum occurrence class, entropy, that we'll discuss in our future lectures, contingency, correlation, chi-square test. In ordinal, you can take the median, percentiles, because it is based on order, rank correlation obviously. In interval, you can take mean, standard deviation, Pearson's correlation, T and F test. With the ratio, we can compute geometric, harmonic, or percentage variation. Then the properties are that you can take any permutation of values in nominal. For example, if you have employee ID, and from instead of 1 2 3 4 you assign 1A, 2A, 3A, 4A, so it is not going to make any difference to this attribute. Ordinal is order or preserving. Whenever you apply a transformation, it should preserve the order of the original, how the original attribute works. So it's not that fair becomes 3 and good becomes 2. So if the order is 0 1 2 3, so there's a monotonic increasing or decreasing function, or probably this 4 3 2 1, and you are mapping from, let's say, bad and fair and good and excellent. So it should be either monotonically increasing or decreasing depending on the scale, but the order should not change. That is, if you are if fair is coming, if we are taking this order, then fair should come after bad, and it should come before good. It's not that these positions get swapped. It should not occur like that, that fair becomes 1 and excellent becomes 3 while others have maintained a position. So that we have to take care about. uh, but otherwise, if the function is maintaining its order preserving property, any worked function can be used to transform the ordinal attributes. Interval, again, interval should be able to map the proper scale that we are taking. So, and probably if you are taking a shift, then that shift should be applicable to all the values in the interval. So Fahrenheit and Celsius temperatures are good examples of interval. Then ratio is scaling, but ratio should maintain that division property. Here you can, in interval you can add an extra constant which can shift, but here only scaling is required. So what is the difference between ratio and interval attribute types? For that, I would want you to think, when you take temperature in Fahrenheit, Celsius, and Kelvin scale, so are they all equal? Are they considered, are they in the ratio scale, or in are they type of ratio, or are they interval attributes? So is it okay to compare them as ratios of each other, or as intervals of each other? Just think about it. Then when we talk about discrete and continuous attributes, so attributes can be classified as discrete as well as continuous types. Discrete means they have discrete set of values. So for example, zip codes, counts, these values are finite. They are represented as integer variables. And binary attributes will have only two values, and they are special case of discrete values. Continuous attributes, on the other hand, are real numbered values. Examples could be temperature, height, weight, length, and they can be measured and represented using a finite number of digits. And they are generally represented as floating point variables. Asymmetric attributes are attributes where their presence or absence is regarded as important. Generally, the presence is regarded as important. So, like words present in the documents or items present in the customer transactions. For example, if you go shopping and your friend also goes shopping, and you see each other's card and you tell that your friend, oh, I have also not purchased what you have not purchased, so our cards are similar. No, you are not going to say that. So here the presence of certain objects is more important than absence of others. Obviously you are not going to buy everything that is in the mall, and everything will not be there in your cart. So the presence of certain objects is more important than the absence of the object, because these three things are not, these things are not similar to these things. And if the mall has a lot of things, not buying some of them does not tell you the similarity. So two asymmetric binary attributes are needed to represent one ordinary binary attribute, one for presence and one for absence. And generally these attributes arise from objects that are sets, because in sets we talk about presence or absence of an element. Then there are various kinds of data sets that we can talk about. Records, example of which are data matrix, document data, transaction data. Then you have graph, which is the example is the World Wide Web, molecular structures. Order data, you can have spatial data in terms of location, temporal data for time, and sequential data for time series, and genetic sequence data. So records is generally, it's a collection of records, as I told you, with a fixed set of attributes. Data matrix is numeric attributes. Then the data can be thought as a projection into multidimensional space, and it can be represented by a m by n matrix with m rows and n columns. Just consider an image. So this is, an image is an example of a data matrix where these are pixels of an image. Document data is basically, if you can talk about here, presence of certain objects are more important than absence. So they are generally represented as presence of or absence of certain terms. Each term is a component of the vector, and you will count the number of occurrences of a particular term in the document. So what happens is you take a word corpus or a dictionary, and you will have a lot of words in the dictionary. Let's say we take the English dictionary, and we start seeing reading documents. So whatever words are there in the dictionary are organized as attributes, and then you start counting how many words like team was in document 1, then in document 2 how many occurrences of team were there, in document 3 how many occurrences of team were there. You count and then you store. Then how many occurrences of coach, play or ball were there in each of the documents. Obviously these are very limited set of words. There will be a huge word corpus that you will be looking at when dealing with document data. One interesting thing about document data is that for a particular domain, certain words will have a very high frequency as compared to others. For example, in statistics you will have mean, median, modes. These kind of word will appear more than probably genome sequence that is used in biology. So document data is largely domain dependent also. So moving back, the other is the graph data. So the graph data is generally represented as nodes and edges. For example, in the World Wide Web, if you have one document linking to another, you can represent it using a graph. Or probably some chemical molecules can be represented using graphs as nodes and edges. So in the next lecture, I hope I have not missed anything. In the next lecture, we will be talking about proximity measures, that how you compute proximity or distance between two data points. So till then, stay tuned, and if you have any questions, please ask to me in comments. Like, share and subscribe to this channel to keep learning. Thank you.